Good morning. This presentation summarises the business continuity management approach developed for electrical thermal energy storage system within RMRE's Stage 1 renewable energy power station. ETS is the critical firming asset that enables 24-hour renewable generation by storing excess energy as thermal heat. In this briefing to senior management, I will outline the critical business activities that support ETS operations, the key business interruption risks identified in the business impact analysis, and the recommended continuity strategy to maintain operational resilience in line with ISO 22301. This focus is on ensuring RMRE can reliably supply electricity and meet safety, compliance, and market obligations during disruptive events. ETS uses approximately 10,000 tonnes of volcanic rock to store thermal energy and convert it into steam to drive the existing turbine generator systems. This relies on a combination of refurbished coal station infrastructure and new Siemens Gamesa technology. To determine continuity requirements, we identified 5 critical business activities: thermal charging and retention, steam generation, SCADA, and control system operations, ongoing asset integrity and maintenance, and compliance-linked energy dispatch. These activities form the backbone of ETS' ability to supply firm renewable energy, and they are the basis for our business impact analysis and continuity strategy. The business impact analysis focused on 5 major interruption risks that could significantly impair ETS operations. These include heating system failure, control system outage, specialised workforce disruption, extreme weather, and regulatory intervention. Each risk was evaluated using maximum acceptable outage, recovery time objective, and recovery point objective. The analysis showed that 2 areas require the most urgent recovery capability: the heating system itself and the control and monitoring centre. Even short interruptions in these areas compromise RMRE's ability to dispatch energy and may result in market breaches, financial losses, or safety issues. The full risk assessment and the MAR, RTO, RPO tables are provided in appendices D and E. The highest impact disruption scenario is a failure of the ETS heating system. This prevents the volcanic rock from reaching operational temperature, which stops thermal energy production and eliminates our ability to dispatch power during high demand periods. This event has significant financial and regulatory consequences, including the risk of breaching supply obligations. It also impacts asset integrity because prolonged inactivity affects turbine temperature stability. Because of these impacts and the short recovery tolerance identified in the BIA, heating system failure is a selected scenario for a full continuity strategy. The continuity strategy includes both preventative and reactive capability. Proactive measures focus on reducing the likelihood of failure by installing redundant heating circuits, applying condition-based maintenance, conducting quarterly OEM inspections, maintaining an inventory of critical spares, and strengthening cybersecurity across the industrial control systems. If a failure occurs, contingency measures are activated. These include a backup dispatch plan with network operator, a rapid response maintenance team on a 2-hour mobilisation window, escalation to Siemens Gamesa for complex faults, and temporary boiler support if the outage extends beyond 24 hours. Together, these measures provide RMRE with the capability to maintain minimum generation and restore full operation efficiently. In conclusion, the BCM assessment confirms that ETS is vital to RMRE's ability to provide continuous renewable energy. Strengthening redundancy in both the heating system and the control system will deliver the biggest improvement in operational resilience. Regular drills, updated spare strategies, and clear response protocols will ensure that staff can effectively manage an unplanned outage. Embedding ISO 22301 practices across RMRE will further support readiness for future stages of the project. These recommendations will help RMRE maintain supply security, meet regulatory obligations, and protect stakeholder confidence as Stage 1 transitions into full operations. Thank you. Please view the references that were used in this presentation.